Hi, I'm Tony Holland, president of Parkit. We have a special guest today, Ion Toma. He's a PhD engineer. He worked for Philips for many years. He's responsible for many of Philips' first LED patents, including their first LED dimming patent. And he's also responsible for building the first light pipe up a 24-story building that changed color, and it was a beautiful installation. It was groundbreaking.
Shaw Tower,
In the Shaw Tower in Vancouver, Canada. So that was the first.
2006.
In 2006. This is Rene Decchiato. He's the electronics technician who maintained the system that Ion designed for the Vancouver Library's 1,200 parking space garage, and we installed 350 of these lights, as I'd mentioned before. And this is Simon Kim. He's a software engineer who used that garage as his lab to design the new camera-based system that we see in this showroom. So, Ion, let's talk about what we had to do, or what you had to do, to make this whole system work. Because I said to you, look, I want to make a wireless parking guidance system. Nobody else has done it. Can you do this? And you just come from Philips.
Yes.
Yeah, that company got bought by Philips, and you'd worked for it for a while, and then you wanted to be on your own, and you said, I'll come and work for you. If any patents that we get, I can share it with you.
Yes.
You want to have your name. So I said, great, that's fine with me. So let's do it. So we came up with this. This is the bare bones of the fixture. This is the outside of the fixture. And like I say, when there was empty spaces, this would be green. And when there were full spaces, it would be red.
Yeah.
So that alerted drivers to the parking guidance world. But we had to do something that nobody else had done. We had to invent a new protocol.
Wireless protocol.
A wireless protocol. So you chose 950 megahertz.
950 megahertz, yes.
And you chose that one because it had a greater range than any of the others that were available. And a lot of those bandwidths had already been taken by other companies. And so we had to choose that, and we had to get it through FCC.
Yes, certified by FCC,
Yeah.
And CSA.
And CSA.
FCC United States and CSA in Canada.
And for that, we had to rent or buy a whole bunch of very, very, very specialized equipment.
Yes.
And it was a long process.
Yeah.
But we did it. And the range of that was something like a kilometer.
Yes.
900 meters, I think it was.
Exactly.
And
free air.
Yes,
straight in a
straight line.
The pillars and
yes,
corners
and then the Hydro Authority, BC Hydro, our local electrical utility, came to us and said they've been keeping an eye on us. They said, we found a garage that you can put your installation in. It belongs to the city of Vancouver. It's under the Vancouver Library, and it's unfortunately for us, or maybe fortunately, it was an oval building.
Yes.
Built like a coliseum, and there were all sorts of barriers inside the garage. There were concrete pillars, corners, and concrete storage rooms within the garage.
This is just one floor.
This is one floor. There were 3 floors.
Yes.
So to circumvent, or to make sure the signal traveled properly around the garage, Ion put in a main receiver, master device, and then each of these other lights had its own circuit board, and that is the circuit board that Ion designed, and we made.
Over here is the wireless system.
And it's got a copper box around it because to dissipate the heat.
It's shielded.
It's shielded. Oh, yes.
Shielded.
Yes. And so we had to create all these other submasters. to make sure that the signal traveled to all the spaces, because this space was lower, this space was
And every
concrete.
submaster was responsible for surrounding slaves.
Right.
So we have light masters and submasters and slaves within the floor.
Another thing that you had to invent, and I know you had to sleep at night and wake up with the right idea in the morning. But
yeah, but I didn't tell you about that. I told you today.
He told me today.
So
He was
wireless protocol.
He was going to call me while I was on holiday and say no, we can't do this. But then he woke up the next morning with the right answer, and so you didn't have to call me, right?
Yes.
Yes. And did that concern the dimming? Because there were only 2 dimming systems existent in the world at that time, and one belonged to Philips, and I think the other 2 Acuity.
They were patented.
They were both patented.
Yeah.
So Ion had to put on his thinking hat, and he had to think, how am I going to invent another type of dimming system for our installation? So, but you did it.
Yeah.
You did that.
We together.
Well, kind of.
Yeah.
You did most of it. But then we did take out a patent.
Yes, we did.
And we still have it.
Yeah.
And we're still partners in that. So for several years, this system existed in the Vancouver Library. And Renee became the one who had to maintain it. So Renee spent many hours as we modified and upgraded the equipment. We have this little power supply here, which gave us trouble. And we had to go around to every light
and open it
and take it out.
Yes.
And put in a replacement.
Yes.
And then we also had, yes, you're going to say something?
So the problem was generated by huge fans.
Huge fans.
Located on each floor.
Oh, yes.
And when they were turned on,
a big spike would come into the electrical system.
Yeah, we had big spikes.
Yes.
In the electrical system.
Yes.
So initially we had a power supply that was certified, bought from United States.
Yeah.
For 380 volts, but it wasn't that good.
No.
Yeah.
And so
we realized that after we installed the system.
I think it was Boston Dynamics that gave us.
No. So I don't know.
I knew it was a company in Boston.
Oh, yeah.
I sent an entire fixture back to them, and their engineers worked on it, and they said, we have a new power supply.
Yeah.
We'll send it to you. And then Renee went around to all 350 of them and took them all out and put new ones in. And we also had problems with the surge suppressor.
Which is related to those spikes.
Which take out those spikes. Yes. Yes.
But other than that, we didn't have any problem with the wireless system, with the communication, with the central computers.
Right.
And so this was the only problem.
And this ran flawlessly for many years.
Yeah.
But what we had to do to make it work at that time was we didn't have any other way to detect whether a car was in a space or not, other than to put a sonar sensor above the car.
On top of the car. I mean above the car.
It's like X fixture.
Yes, which meant that each fixture had to have 6 sonar sensors going above the cars, and it worked pretty well. Unless you had a sports car or something, it worked pretty well. We also invented and drew up, the software guys at that time drew up a screen that could report
exactly like that.
That could report.
We were able to see this remotely.
Yes.
On our PC here.
Yes. And so could the customer. Yes. And we also reported how much power we used.
Yes.
And I think we saved $65,000 a year in lighting costs from the former installation.
And on each light we had movement sensors.
Yeah, a motion detector.
Motion detector.
To dim the lights.
Detecting the people.
Yes.
Walking in the garage. and
Yes.
also the cars.
Yes.
So practically we were able to follow
Yes.
a car remotely on our PC here.
Yes.
We were able to track how the car ended up from here to here, for example.
Yes. And I remember we went down to the very basement one time.
Yeah.
It was empty, and we went around with a motorcycle, and the lights just cascaded on one after another as we went around in groups.
Yeah.
You know, it worked really, really well.
And we were able to save energy
Yeah.
by dimming the lights if in the
Yeah.
library there was no movement.
Exactly. Exactly.
And
and that was at nighttime.
Motion sensors
Yes.
were going on, detecting
Yes.
in front of people walking
As they were walking.
cars. Yeah.
Yes.
So it was about saving energy.
Now, Simon Kim is our software engineer.
Yeah.
He has built upon that because we realized at the time that those sonar sensors
Yes.
were not the answer, because it cost so much to put in all that wiring to maintain those sonar sensors.
But they were reliable.
They were reliable.
100%.
But then we decided to switch to cameras.
Yes.
And then that's when Simon came into. Simon's our software engineer. He's a master's degree in wireless software engineering. And so he came in, and we got a portion of this first floor, and we put a portable lab down here, and Simon sat in that lab for over 6 months, every day, measuring and recording all the movements of all the cars and taking photographs of each of the cars as they parked. And we developed the master plan for that, for detecting whether a car was parked in a space or not. We had to use AI.
Yeah, at this moment we are used machine learning. After that, now we are using AI.
And back in that time, you used machine learning.
Machine learning, yes.
Which
this machine learning, I needed several
computers. Yeah,
several photos. That is why we gather the data. After that, we use the AI using same data.
And then, so a couple of years later, now they'd come out with AI, and you were able to do it much more quickly.
Much quicker.
But I think it took several days to process those 25,000 photographs you first took.
Actually, we didn't use all the 240,000 photos because most of them is similar.
Yeah.
We need to choose
the ones.
And to train the AI.
Yeah, to train the AI. And so for many years, we maintained and improved this library, this system throughout, and we were able to use it as our laboratory, and we had very, very positive feedback from the authorities, etc., etc. We broke ground coming out with the first one, and now we've come out with the first completely wireless camera-based system. So no longer are we analog like all the other parking guidance systems. We are digital, which gives us the opportunity to do many, many, many more things with our technology. So thank you all for coming and seeing what we have and what we've done, and the great people who actually built and maintained the system. So